Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on zeros, singularities and poles. Lecture number 11, in which I will prove a theorem and solve problem on the point at infinity. Now we prove a theorem. Statement of the theorem is, let function of z fz be a function defined in some domain D, and let the function g be defined by g xi equal to f1 by xi. Then the function f, number 1, is analytic, or number 2, has a zero of order m, or number 3, has a pole of order m, or number 4, has a removable singularity, or 5 number, has an essential singularity at z equal to infinity, according as the function g has same behavior at xi equal to 0. That is, according as g is analytic, or has a zero of order m, or has a pole of order m, or has a removable singularity or essential singularity at xi equal to 0. Then the function f has same behavior at xi equal to infinity. Now we prove this. Prove. Let g xi equal to f1 by xi. This is number 1. Let 1 by xi equal to z. Therefore, fz equal to g xi. This is number 3. Now we prove 1 by 1. Number 1, f is analytic. Here let g xi is analytic at the origin, that is at xi equal to 0. Since z equal to 1 by xi, here 1 by xi tends to infinity as xi tends to 0. If xi is 0, then 1 by xi tends to infinity, and 1 by xi is z. That is, z tends to infinity as xi tends to 0. This is number 5. Therefore, from 3, 4 and 5, we get that if g xi is analytic at the origin, that is xi equal to 0, then fz is analytic at z equal to infinity. Number 2, let g has a zero of order m at xi equal to 0. Therefore, Taylor expansion of g xi will be g xi equal to sigma n equal to m to infinity a n xi to the power n. Since 1 by xi tends to infinity as xi tends to 0, therefore using 2 and 3, we get into 1 by xi equal to z, that is, and in 3 g xi equal to fz. Here fz equal to sigma n equal to m to infinity a n 1 by z to the power n. This is number 8. Since limit z tends to infinity, fz equal to 0, this is infinity, then this is 0. Therefore, fz has a zero of order m at infinity, z tends to infinity. Number 3, let g has a pole of order m at xi equal to 0. Therefore, by Lorentz expansion, z xi will be equal to sigma n equal to 0 to infinity a n xi to the power n plus the principal part will be sigma n equal to 1 to m bn by xi to the power n. Since 1 by xi tends to infinity as xi tends to 0, therefore expansion of fz at infinity will be fz equal to sigma n equal to 0 to infinity a n by z to the power n plus sigma n equal to 1 to m bn z to the power n. By using 2 and 3 we get this. Therefore, function of z has a pole of order m at infinity. Number 4. Let G has a removable singularity at xi equal to 0. Then in the neighborhood of 0, G xi will be of the form G xi equal to sigma n equal to 0 to infinity a n xi to the power n. Here we will not get any term in principal part as it is the removable singularity. Hence at infinity function of z will be fz equal to sigma n equal to 0 to infinity a n by z to the power n. This shows that function of z has removable singularity at infinity. Number 5. Let G has an essential singularity at the origin. Then the Laurent expansion of z xi at xi equal to 0 will be of the form z xi equal to sigma n equal to 0 to infinity a n xi to the power n plus sigma n equal to 1 to infinity b n xi to the power minus n. Therefore, at infinity, that is using 2 and 3, we get fz equal to sigma n equal to 0 to infinity a n by z to the power n. Here 1 by xi equal to z plus sigma n equal to 1 to infinity b n z to the power n. This implies that fz has essential singularity at infinity. Therefore, theorem is proved. Now we solve a problem. Problem is so that the function e to the power z has an essential singularity at z equal to infinity. Solution. Let function of z equal to e to the power z. Now let z equal to 1 by xi. Since 1 by xi tends to infinity as xi tends to 0, let phi xi equal to f1 by xi. Here 1 by xi equal to z, that is this equal to fz. Therefore, nature of singularity of fz at z equal to infinity will be same as the function phi xi at xi equal to 0. In the theorem, we have already proved this idea. Therefore, phi xi equal to f1 by xi, f1 by xi equal to e to the power 1 by xi, and we expand this 1 plus 1 by xi plus 1 by factorial 2 xi square plus 1 by factorial 3 xi cube and so on. The principal part is here 1 by xi plus 1 by factorial 2 xi square 1 by factorial 3 xi cube plus dot dot dot, which contains infinite number of terms. Hence xi equal to 0. Here xi means xi minus 0. Here xi square means xi minus 0 whole square. Therefore, xi equal to 0 is an essential singularity of phi xi. Consequently, z equal to infinitive will be essential singularity of fz equal to e to the power z. Therefore, z equal to infinitive will be an essential singularity of e to the power z. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.